Okay, let's get started. Good morning or good afternoon, everyone. Thank you all for being here and making the time to attend this important webinar on the topic of blockchain. My name is Prashant Shetty. I'm the Vice President of Marketing for Guardian Analytics. We are a leader in behavior analytics and machine learning-based solutions for financial crime fighting. Today, Guardian Analytics is very excited to co-present with our partner PwC on the topic of blockchain and to articulate our point of view on this innovative and disruptive technology that is arguably one of the most transformational to come about in many years. This particular P2P distributed ledger framework has truly some tremendous potential impact in areas encompassing verticals including healthcare, financial services, and real estate, and also wide-ranging applications including trading, money movement, identity management, etc., and any sort of exchange assets. Now, today's talk is really focused not just on the potential opportunities. We know there are many of those for blockchain, but also to shed light on the risks, especially the financial crime-related ones, such as in fraud, money laundering, and cyber fraud, as well as what can be done to actually mitigate that risk. So it's with great pleasure that I invite Zion Mitrani. He's a partner at PwC and director of the anti-fraud practice at the Financial Crime Unit at PwC to share his informed perspective on this topic. But before we get to that, a couple of quick administration items. We're going to take as many questions as we can and address them at the very end of the session. The session is scheduled to last about 45 minutes, so we will end at 45 minutes past the hour. Please submit your questions in the question section of the control panel of the GoToWebinar. So with that, we have some great content lined up, so without further ado, let me hand over to Zion.
Thank you, Prashant. Thank you very much. I want to thank everyone for taking the time to join the webinar and Guardian Analytics for hosting this webinar. For me, it's a pleasure speaking to such an exciting and very broad topic of blockchain technology and risk. Kind of short introduction. So my name is Zion Mitrani. I'm a director of PwC, part of the Financial Crime Unit in our fraud prevention practice. Something that I have the controls. Yeah. So I've been working the last 20 years in IT and 15 years out with them in fraud prevention, assisting financial institutions with developing, implementing, and optimizing their fraud prevention programs. I started my career in fraud prevention on the vendor side at RSA, building a fraud detection solution for the ground up. If you're familiar with the RSA Adaptive OSP solution and the 3D Secure solution, I led the risk engine, product development and analytics and detection engines. From there on, I moved to consulting, build and led a fraud prevention services practice, helping clients from the US and EMEA with a fraud program, mainly technology side, developing solutions and leading technology implementations, model tunings and analytics. I joined PwC a year and a half ago to continue helping financial institutions prevent fraud and mitigate risk. As I mentioned, I'm part of the PwC Financial Crime Unit. This is led by former Deputy Director of the FBI, Sean Joyce. It has more than 600 professionals. The Financial Crime Unit is formed 2 years ago, I guess, to unify 4 separate pillars: the cyber, AML, fraud, and ABAC, the anti-bribery, anti-corruption practice, into one. As we see nowadays, financial crime spans across the 4 areas, and they move along from one to the other. We believe that our clients will benefit from such a holistic view and multidisciplinary approach, I may say, for fighting financial crime across these boundaries. Our fraud prevention practice service cross end-to-end consulting from strategy, policy, governance, operating model through technology design, implementation, analytics, investigation, and much more. And we have a lot of thought leadership that they contribute to the market, different aspects of fraud prevention, omnichannel authentication, faster payments, open banking APIs, lines of defense, and more. So we will obviously cannot cover all the aspects of this technology and its growing ecosystem in this session, but we will try to touch upon some of the aspects that are relevant to risk and fraud. So all aspects of our lives are influenced by this digital age or digital revolution we're living in, and this is a digital enabling technology. My personal belief is that blockchain technology will have a profound impact on the way we transact, on the way we store and transfer value, and even I go further to say on our society structure itself. So a lot has happened since November 2008, when an author who named himself Satoshi Nakamoto sent a paper to this mailing list of cryptocurrency. The paper was called Bitcoin, a peer-to-peer electronic system. This paper basically outlined this electronic system for transaction, which is not relying on trust. That's kind of one of the important parts of that. Now, though the Bitcoin itself, and other cryptocurrencies and tokens are built on the blockchain technology, one of the understanding is along the time the significance of this underlying technology and the way that it can affect our businesses. I want to start in touching maybe the enormous growth in this field, interest, investment, development, adoption of the technology. That can be seen across multiple verticals. Moreover, this growth seems to only accelerate. I think it will be in 2017 as the year of the cryptocurrency break. There is a feeling that is somewhat similar to what we had in the 1990s when the internet revolution was started. And I'd say that for the good and for the bad of that. To give you some sense of this growth and the size of that, if you look at the investment in the blockchain-related companies, it is growing. In 2017, traditional VCs investment got to $360 million, and investments through ICOs amounted to $1.3 billion. So what is an ICO? An ICO is an initial coin offering, which is kind of a reference to initial public offering, which is basically the next level type of crowdfunding. That is, a company will issue a token, a virtual currency that might considered as a digital asset in some cases for sale. Usually this is built on the Ethereum network. I will talk about Ethereum network and smart contracts later on because I think this is a very interesting and important technological development as it relates to the blockchain technology. So funds are raised through this ICO and then used for developing the technology and building companies and solutions. That became kind of the major vehicle for fundraising within the industry. Not without hiccups, there's some regulatory scrutiny towards the ICO as there's no regulation currently surrounding the ICO's process, not the related taxation or the responsibility towards the investors, etc. Lately, the SEC conducted what they call an internal investigation and published some kind of ICO. And they mentioned that ICO might be considered, at least in some of the cases, as securities, and they will be subject to federal security law. But still, ICO numbers are growing, and even VCs and traditional investment companies are leveraging this model. Another vertical that we can see the growth in is the cryptocurrency market size itself. If you look at the cryptocurrency market size, there's more than 1,000 coins and tokens out there in the market. At January 2016, that was all as a whole worth like $7 billion. At January 2017, $18 billion as we speak. When I was writing the some of this content, it was 130. We passed the $140 billion for 2017 at this point, which is about 7 times folding 2017 alone. If we look at the adoption, there's a major adoption between 2017. First of all, from people perspective, the number of accounts, if you take, for example, Coinbase, which is one of the leading exchanges and wallets in the US, and actually the first unicorn startup in the field just raised $100 million with a 1.6 billion valuation. It has more than 1 million users, more than 30 million wallets to store currency, and more than 50,000 merchants. If we look across governments, so there's adoption by governments in 2017 as well. Japan in March 2017, through a Virtual Currency Act, they could legalize Bitcoins and virtual currency. Hundreds of thousands of stores will be accepting and in the process of accepting Bitcoin and virtual currency. This contributed dramatically to the demand of the currency and to the development and maybe into the legitimizing of this area as well. Australia as well canceled their double taxation, I think it was 1st of July this year. And that's part of a commitment to become a global technology leader in virtual currencies and financial technology. Russia is showing interest in technology as well, the World Bank as well. And again, probably every company is looking into the technology at different levels of progress. If you look at corporate, there's a big adoption as well. There's a big embrace by big businesses. This is not a closed community anymore. The realization of technology potential makes many big corporates involved. Most of them are involved through the Ethereum Enterprise Alliance, which is basically, so it has a lot of Fortune 500 enterprises, startups, academy, and technology involved in that. And the aim is to build upon smart contracts to supporting the blockchain. And again, I'll try to touch upon the smart contracts later on as well. So the idea is to try to create an enterprise-grade level software building, utilizing the technology. And there's a lot of investment from IBM and Microsoft, who just published some of their development last week, MasterCard, and many banks worldwide. If we look at the technology, it's definitely maturing. We have scaling is one of maybe the biggest challenges of the technology. There's a big improvement with the SegWit implementation acceptance that paves the way to more transactions being processed by the system, but still that is not enough. Smart contracts, again, on the Ethereum, is one of the most promising development in the field, with promise to extend way beyond currency and financial solutions. If you look at the banking industry, 80% of the banks plan to initiate projects on blockchain technology in 2017. Just by looking at, as well as the mining size, where mining pools are growing in size and profit, they have an impact on the GPU consumption around the world, whether it's NVIDIA or AMD. SHA power, again, hash rate stronger than any computer in the world nowadays. The electricity required for actually confirming transactions on those networks are probably the consumption of a small country. We'd like to touch upon some of the blockchain technology, some of the advantages and disadvantages that one would look. This is not a solution for everything, as people sometimes may think. And I'll talk about the private and public as well, and then some technology advances, especially the smart contract ones. So some of the blockchain key features is, this is a distributed ledger, a database, basically. It's a means of storing data in a decentralized way based on cryptography. That's essentially assume no trust. At least this is true for public blockchain implementation. So this is distributed peer-to-peer network. There's no intermediate, which is an essential property of the system. It has a time step or a public recording of the transaction that can be linked together. Each transaction is signed by the creator, and then this is verified and then added to a block. So in that sense, there's some properties of a read-only database to the technology. The technology is very, very secure, obviously by construction, the uses of private public key encryption, the hashing. Hashing makes tampering with the network very easy to detect, as the hash value will change if somebody changed something in the chain. So a deletion or insertion action requires many members to collude together, and yeah, there is a risk here for more than 50% of the people to somebody take more than 50% of the network, but still very secure. There's many advantages to the technology. There's no central point of failure, which is an important part of that. There's no need for the DR by definition. Data is distributed along the nodes. It's easy to audit because of the ledger, and it solves the double spending problem, as transaction will not be approved if you are not the owner of this address to begin with. And there's some potential for lowering costs for specific cases to begin with already nowadays, but as the technology will evolve, there's many opportunities out there. Some of the disadvantage is, as I mentioned before, it's very hard to change something within the network because of the 51%. So no reversing or mistakes or chargebacks are feasible on the network. Another thing is the cost of the nodes and the multiple processing for verification. It's one of the disadvantages in a way. You know, the power required now for verifying one Bitcoin transaction is equal to about 36 hours of powering a regular household. So just to give you a sense of that. One of the biggest advantages probably is that disadvantage is probably that this is still a new technology, and therefore it is prompted for risk, and we'll touch upon that quite soon. There is a big difference between the public and private chains, mainly along these two features. So the assumption of trust is something that you know, in public chains there's assumption of no trust. In a private chain, this can be participant basically can validate the transaction for the whole group. So that means you need fewer nodes than the public one. As well, in terms of cost, there's not necessarily the need of the proof of work, which is part of the current mechanism of the public chain. There are some approaches in the work for addressing that, and I will mention that soon. Looking at technology development, the way I see it is there's two main ones that you know, we should talk about. One is the scaling. As mentioned, this is one of the major challenges of the technology that will have to be addressed to be a viable solution and to compete in the market, especially as being a payment system. Bitcoin can process something like 10 transactions per second, while if you look at Visa and MasterCard, they process more than 2,000 transactions per second. So in cases when they were loaded on the networks, sometimes transaction waited hours to be processed. This is costing increasing fees. People try to offer more fees for processing their transaction to get a priority and such challenges. I think this is something that must be addressed. Recent changes to the network, you know, help that in a sense, but there's still a lot of work to be done. So I mentioned SegWit before, and maybe the increase of the block size will improve that, but it doesn't still seems to be enough, but I'll get back to that soon. Another very important aspect of this technology, and one of the most promising, is the smart contracts. Ethereum Bitcoin younger brother was established in mid-2015 by Vitalik Buterin. He was 21 years old at the time. I believe that this is the most promising development in the blockchain. So it's running the Ethereum virtual machine that basically can run scripts using these public nodes. That means that these smart contracts are these stateful, decentralized applications that are stored on the Ethereum blockchain for execution by the virtual machine. What that means is basically that a developer can now write code which opens the platform basically to endless possibilities using there's an inherent language, Solidity, and there's a few other languages that are being developed nowadays and compilers to create solutions and applications which are sometimes named DApps, as a distributed applications. Actually, I think that yesterday, Ethereum, the Ether network processed 400,000 transactions. This is the record for every cryptocurrency ever. It surpassed Bitcoin by more than 50,000 transactions. So it is growing. There's huge adoption to this network. Ethereum is responsible for most of the ICOs I mentioned before, this initial coin offering, and most of them, of those tokens, are built on top of the Ether infrastructure. Sorry. Ether development roadmap and future versions are very promising as well. We mentioned scalability. The plan is probably next year or so to move from the proof of work to proof of stake, which will reduce costs associated with CPU power of the proof of work and help scaling as well. There's other few solutions that should help scalability. Things like shredding, which is a method of partitioning data that could improve scalability. In recent, I think last week, a recent paper came out, a joint paper by Vitalik about a solution called Plasma, which has the promise of scaling the framework of the Ether, considering even up to 1 million transactions per second, and that will be really interesting to see how that develops. So this technology now can facilitate maybe development. We see many implementation within financial institutions. Obviously, payment is a natural one. Money transfers. We see the cross-border transfer as being the first use case as simplification of costs. Here is it's a good business case to start with, but obviously settlements, escrow are a viable solution as well. Outside of banking, you can see solution for supply chain because you can track things along the supply chain. The solution for voting, gambling, databases, even a project that tries to build a kind of this big distributed computer. Music industry has some implication. Distributed web is one of them as well, and so on and so forth. Talking about the risk. As we mentioned, this is a new technology, and obviously that comes with many risk verticals to it. The first one I will touch upon is obviously fraudsters and cyber. The very design feature that makes the Bitcoin technology appealing to users are also appealing, obviously, for fraudsters. So the blockchain is decentralized. It's kind of pseudo-anonymous. It's unregulated to most extent, and therefore it's ideal for committed fraud. The rewards are potentially very big within the ecosystem nowadays, and moving the money, funneling the money out is rather easy nowadays. If you look at some of the examples of things that we have seen over the last few months, so ransomware attacks, the WannaCry malware that's using a Microsoft Windows exploit, which was discovered by the NSA. They're using that to encrypt the computer and demand a ransom in the form of Bitcoin. This affected more than 200,000 users and computers around the world. In that case, about more than $70,000 were actually earned by the fraudster. Though there was a case in June that a company in South Korea paid more than $1 million for such an attack, and this was after negotiation. The fraudster started from $4 million. Another case was 153,000 Ether, which was about $30 million, were stolen. This used an exploit of vulnerability in the parity multisig in the wallets that keep the currencies. In that case, a wide group of hackers actually saved more than 300,000 Ethers as well, which is around $100 million, and returned that to their rightful owners. Exchanges have been hacked over time, user data and money was stolen. BitHump, South Korea exchange is a good example for that, and DDoS attacks are happening all around. To mitigate, obviously, the same things that we know and have learned from cyber and fraud are obviously applicable here as well. So the risk from the fact that this is being a new technology, so obviously there's some immaturity that presents a risk. An example is the DAO Attack, which use actual contract code to drain more than 3.5 million Ethers, which is a very big sum nowadays if you do the math. This exploit risk will continue. Smart contract language is complex to QA, and it's prone to errors, especially by unprofessional developers, which we will see more and more tools evolving to try to address this problem. JP Morgan actually developed a decompiler called Prosody to assist debugging the process, but still, again, with this great investments by Microsoft and IBM and others, we will see that they will reduce some of the risk, but there's some still unknowns out there, and I'm sure there will be some more cases that we'll see in the future. If you look at the external user, from the external user, there's first of all the need to maintain the keys, right? Either by a third-party wallet, there's still a risk there. On their own computer, that still can be hacked, or malware can get to that. Some people suggest that paper is the solution to go. This will mature as well. There is some devices nowadays being sold out, so you can store it outside of the net and things of that sort. But that's still a risk. An example for that, by the way, there was an IT worker in London that threw away a hard disk which has more than $7.5 million worth of Bitcoin, and that was lost forever. There's another risk when we look at the wallets. The wallets, this is the tools where the people hold their cryptocurrency or virtual currency. Here, there's the natural risk of an account takeover, which, again, we're in the industry of fraud, have dealt with that for many years. So this is definitely a risk and should be mitigated with controls around the account takeover. So things such as authentication controls, two-factor authentication, monitoring systems, need to understand and learn your user behavior, leverage advanced analytics for that, and things of that sort should be leveraged to mitigate that. There is some concern or risk to user that regulation is not that fully developed, so aspects of taxation or even investment in ICOs and others is still there. If we look at the private chains and the internal kind of user risk, there is a risk. First of all, there is the risk of internal fraud or employee fraud. So a person with an access to the payment transfer system and affect the system. Back office system hacking, and again, that's another risk. This is the same use case or risk that we have seen in the Swift Bank Bank of Bangladesh attack where 81 millions were stolen over the SWIFT network, there's a similar attack. So I think that after this event, they have controls to access controls at the back office, authorization procedures. But after the Bank of Bangladesh attack, that demonstrated that there's a need to have a detection monitoring system at the back office as well as part of the layered security defense. That is, if access is bypassed, monitoring systems has potential to still detect and prevent a loss based on either anomaly detection or behavior detections, etc. If we look at the exchanges, so there's risk as well. People are holding the money in exchanges and they feel they're safe as they're used with security, but that's not necessarily the case in this field. One of the examples, there was a technical issue or hacking at the famous case of MTGOX, the biggest exchange at that time, that caused an alleged loss of 850,000 Bitcoins, which in today's value, it's almost $400 billion, leading the exchange to bankruptcy and leaving many customers with big losses. We do see hacking attacks on exchanges, and obviously there is still, again, the aspect of an account takeover, that is, exchanges should work on how to protect their user from an account takeover. So again, onboarding controls, authentication controls, fraud detection and monitoring controls should be put in place. Last but not least, regulatory risk. This is new technology in a new ecosystem, and this is an evolving one. Regulators are starting to address some of the new developments it brings, but still there's no full guidelines in some of the cases and clarity. I'm sure that will come about as time will go, as time will pass. Again, one of the examples that we mentioned, the ICOs and the SEC directional statement towards that. So this is one example. Though they chose at that example, this particular case, they gave the guidance that this should be subject to federal security law, but though they chose not to take steps to historical events such as the DAO offering, etc. If we look at the AML regulation, there are further complexities here, as not all digital currency adhere to KYC requirements, and anonymity can definitely lend itself to money laundering. So Bitcoin and Ether reveal the sender, the recipient, and the amount of the transaction on the distributed ledger, so transaction can be tracked, but then not necessarily be connected to a specific person. But if you look at other cryptocurrency projects or solutions that are coming out there, BitShares, for example, hides the amount. Monero makes it harder to identify the sender and receiver by mixing transactions together, or they have a mechanism to achieve that. Zcash, another coin within this environment, shields all the data by a mechanism called ZK snarks. So that's something that needs to be addressed, and I'm sure regulatory will mature on that, and this is something that we'll see. Exchanges in the US, at least the major one of them, do enforce the KYC, but still it is hard to regulate. That's essentially part of the reason you see the SEC is at this point not approving ETFs for Bitcoin and Ether, and part of that reason is their lack of ability to fully regulate this solution. So I hope you found that helpful and interesting. Prashant, I'll hand it to you at this point.
Great, thanks for that, Zion. Very fascinating stuff and great insights there. Hey, one question before I take over. So you mentioned the risks to the blockchain ecosystem in your last slide. What can banks and financial institutions do from a controls and governance perspective, procedure standpoint, to mitigate that risk?
Oh, yeah. Thanks for sharing. That's a great question, and a great concern for the financial institutions. For the external users' perspective, so as adoption continues, it will get even more into the traditional banking. There's now a private Swiss bank that's offering its clients to buy different currencies and to store within the bank. So here we see start of the mix of accounts being joined into the banking industry. Fidelity started showing values of this currency and show its belief in this road. So as we see this maturing the adoption, we will see this integration coming into traditional banking, and therefore that should worry us. So you know, as we look at the wallets and exchanges, some of them now are already connecting to banks through APIs and through other mechanisms. So there must be controls to protect against those. So some of them is the monitoring, right? Authentication and onboarding controls, which we are very much familiar with in our fraud prevention programs. And banks have a lot of experience with fraud prevention. So many of those controls are still applicable. I think one of the most relevant approaches to that will be obviously to monitor the behavior of the users, to see if you know, external accounts are being added or payees or some amounts which are not traditional to the way a user behaves. Changes in an account, email, phone, and other patterns that we are very much familiar from fraud will be apparent here and should be addressed to protect from account takeover. As this is digital fraud, so digital controls will assist as well. There's a great development in authentication controls over the last few years. So new biometric authentications, better risk assessment at the point of decisioning on the authentication, better onboarding controls, whether digital, you know, that takes documents and verify them in real time and basically looks at the picture aliveness and compare that as well as part of the protection. For the internal cases, again, controls from internal fraud and hacking, and again, this is things that we are familiar from fraud. They should be applied to this field as well.
Got it. Thank you. That makes a lot of sense. I'm going to take over for a few minutes. I'm going to do a quick introduction about Guardian Analytics and just give you a kind of a high-level overview of our approach that's centered around behavior analytics and machine learning, and how that is relevant and can be applied to the blockchain context. First, a quick introduction about Guardian Analytics itself. As I mentioned, we are a Silicon Valley company, software company founded about a decade ago, and we were one of the early pioneers in leveraging behavioral analytics and machine learning, specifically for financial crime fighting. Today, we serve nearly 450 banking institutions as well as enterprises in their fraud prevention efforts. We protect nearly about 40 million accounts, and annually we monitor and score roughly about 5 billion banking activities. Next slide, please. So as I mentioned, we're in the financial crime fighting or risk mitigation business. But how exactly does behavior analytics work? For those of you who are new to this topic, I've sort of tried to explain it in a four-step process here. It starts with first gathering data, lots of data about the user related to their online activity, in this case, you know, online banking activity, and also transactional activity, could be, you know, payments, deposits, etc. And we run them through our algorithmic models and essentially score it and compare it to sort of a baseline or known user behavior. So we score pretty much every single user or account in the bank or financial institution, and essentially compare ongoing activity with a statistically established baseline. And we flag behavior that is considered statistically anomalous for that particular user, and that in turn drives action to mitigate the risk. So essentially, this is based on a method of checking what accounts for patterns of behavior and what deviates from the norm. But the outcomes that it generates are you know, fewer false positives, a higher fraud capture rate, and overall operational efficiency for a fraud team or a compliance team. And this has been proved over and over again. Next slide, please. So when we talk about our approach about behavior analytics and machine learning, we feel it can be applied in the blockchain scenario as well. And for the purpose of kind of segmentation, let's look at one example in the private blockchain scenario, and another one in the public blockchain. As you may well know, the real difference is that in the private blockchain, it's mainly a closed group of participants, typically higher levels of privacy, lower costs, and more control. The public blockchain, on the other hand, is a more open group with open, participation, lower privacy, but they get the benefits of the network effects. Now, there's also a concept of consortium, which kind of comes in between, but for the case of simplicity, we'll just go with private and public. So in the case of private blockchain, here's just a high-level architecture of a typical, private blockchain system that a financial institution might deploy. Now, a private blockchain typically increases the number of sort of vulnerability points or points of entry for attack beyond what we normally see in a standard sort of online banking or payment system. I think some of you may be aware of some of the downsides, like the theft of private keys in a blockchain, or the so-called 51% attack, where one attacker has potentially more computational power than the rest of the network combined. So bad things can happen. But the good news is that many of the ways in which these organizations use behavioral analytics today to mitigate risk can be applied in a private blockchain-based environment as well. So whether the attack is driven either by social engineering or account takeover, or even an internal employee threat, by using machine learning, we can identify anomalous behavior within an account compared to the historical norms to prevent fraud before it actually occurs. So there's a way of still looking at the underlying principle of behavioral patterns to mitigate risk potentially in a private blockchain. Next slide, please. Now, in a public blockchain, it's equally interesting. We can look at risks that are both of a reputational nature as well as a regulatory nature. So the diagram basically shows a high-level architecture of sort of a public blockchain system featuring a cryptocurrency exchange or wallet in terms of a value-added service that the financial institution is trying to provide to its customers. But here again, the main goal of the financial institution is really to prevent transactions that are involved in money laundering and other forms of criminal activities. So in these instances, machine learning and behavior analytics can still play a key role, but I would say more in an aggregated form. So as a first example, let's look at the reputation of the blockchain exchange or wallet. So with machine learning, we have the ability with our approach to separate our reputable exchanges from failing ones by looking at transaction consistency and volume over time. So we're also able to use this approach to flag bad or malicious players in the system in an immediate and automated way, even if an individual customer has not actually made a transaction to this entity before. So the benefit of this is it enables the financial institution, it benefits the financial institution to protect their customers from losing money to bad exchanges, and can also help you identify those of your users who might be purposefully attempting to fund criminal activity. The second area to talk about in the public blockchain is regulatory concerns. So banks generally need to understand who is sending money to a blockchain exchange, for example. An individual who appears to be just investing money for diversification into Bitcoin may not require any further scrutiny. However, a company that's initiating a transaction, or perhaps a person who opens a new account and immediately moves an entire balance over to an exchange, would potentially raise a flag. And finally, banks really share some of the responsibility for identifying the reasons behind cryptocurrency transactions. So to attempt to answer this question, behavior analytics can support that by surfacing information such as the pattern of funding. Are transactions occurring on a predictable schedule, or do they line up typically with price fluctuations of cryptocurrencies? Where's the money coming from that funds cryptocurrency transactions? Is it a cash deposit or a more identifiable source? And what percentage of the user's balance is being sent to an exchange? So all of these questions can potentially be looked at by machine learning approaches by looking at behavioral patterns. Next slide, please. So the public interest in blockchain-based technology is really growing exponentially, and I think we believe we're only scratching the surface in identifying types of risk and emerging fraud. And the good news about behavioral analytics-based approach or solutions is that they do not rely on an a priori knowledge of fraud schemes. So with our particular anomaly detection platform, we are well positioned to partner with you to prevent fraud regardless of the device, platform, or the underlying technology used. So that concludes my section of the presentation. I certainly hope this session was useful from a standpoint of understanding the current market state of blockchain and the emerging trends, learning about the potential financial crime risks and downsides, and also how behavior analytics and machine learning can potentially be a solution or an approach to address these emerging technology risks. So with that, let's take a couple of questions. I've seen a couple questions that have come through the wire. Let me start with one here. Zion, this question is for you. Looking ahead to the future, what do you think will be the main drivers for the development of blockchain technology, and where do you see the most progress occurring going forward?
Okay. I do think that adoption is something that will keep on growing, and we'll see that. And I think this is the next stage probably is this becoming more and more of a mainstream. So I think the 2.0 version will emphasize more of the usability of digital currencies. We already see increased number of ATMs. It will be easier to transact and so forth. I think this second generation application, so a lot of work has been put into the infrastructure up to now of these technologies, and this shift to the usability and the value to the end user will start to be more and more apparent. So some of the investment that we've seen and mentioned in 2017 and some of the active projects, some of them are very interesting, especially on the Ethereum network, will mature into solutions which will get to end user, and there's many things going out there. Scalability, again, we mentioned that this is one of the main objectives. I'm sure we'll see developments in that. Regulation will step in more and more, though I think they will see more and more adoptions by countries which will form their perspective on this new technology, both using it, both regulating that. I truly believe this is a revolutionary technology that we'll see in the future.
Great, thank you. One more question that came through the question panel. I'm not sure if I fully followed this one. Could you please speak to the scalability and proving out some of these DLT blockchain features? Scalability specifically focus on the number of transactions.
Right. So again, mention scalability. So in the big Bitcoin solution, or what we have seen is really in the last week, the move to SegWit, and then there's some agreement to even move to doubling the size of the block itself to enable scalability. That actually caused a fork in the network. There's a new currency, the Bitcoin Cash, which they're moving into an 8 mega block size, so again, to enable bigger scalability. So these changes are not minor. I think that the main changes will come from what I've mentioned before, which is things that are being developed the Ethereum network, and I think I mentioned some of them in this presentation. So one of them, which the move to proof of stake, which is basically there's no need for doing a proof of work when processing transaction, will be an essential one. But there is very promising work on two things that you can look up maybe later. One is the sharding, which is a very promising solution, as well as the plasma solution for scaling. Again, there people are talking on millions of transactions per second, potentially. And again, that will take some time to mature. There is a roadmap. on the Ethereum development, but that will take time to mature for sure.
Great, great. I think we have time for one more question, Zion. What tools and technologies would you recommend that banks and financial institutions invest in to protect against potential financial crime related to blockchain?
So first of all, onboarding tools. Onboarding tools are very important for, first of all, the KYC portion of that, but for the actual prevention of having mules creating accounts within the environment and so on and so forth. Beside that, our regular approaches for monitoring system, and again, most of the things that we know to do in monitoring systems for prevention are based on behavioral capabilities and behavioral learning, profile building, understanding how our users are behaving, and see differentiations from that, understanding how the general population is transacting and finding divergence from that, and then learning how fraudsters are behaving and finding similarities to that. So behavioral learning, using advanced analytics, on top of that, machine learning techniques, to be able to better detect and understand what the risk lies within the flow of transaction is crucial for the environment. Anomaly detection can help as well here. And for the ongoing, obviously, authentication is a major component. So increasing and strengthening your authentication controls and your risk assessment and point of decisions are crucial for the ability to prevent cases of fraud.
Great. Well, Zion, I want to thank you for the very informative presentation and for sharing your expertise today. Really appreciate it. And folks, that's all the time we have today. I hope you all enjoyed the session and really benefited from the content. If you have any additional questions, please send us our way and we'll make our best effort to respond to it. But for now, thanks and goodbye.
Thank you.